Good day, guys. This is your tutor engineer. We are continuing today with our lessons on graphs and motion in one dimension. So let's start with today's lesson. Reflect on the graphs shown below by answering the questions that follow. Number 1, is the slope positive or negative? So the emphasis is the slope. We're given the velocity time graph. For graph A, the slope is positive since the graph is increasing upwards. So here we'll say number 1, the slope is positive. Then for graph B, the slope is on the decrease, meaning it's negative, right? So here we'll say the slope is negative. Here just notice that the slope is going up. As long as the slope is going up, it means that the slope is positive. So here the slope is facing downwards, so we're going to say it is negative. Now let's go to the second question of acceleration. Is it positive or negative? Remember, the slope of the velocity time graph is actually the acceleration, so you'll have the same answer here with the slope. The acceleration is negative where the slope is negative, and the acceleration is positive where the slope is positive. So basically, it's number 2, I'm sorry. Basically, you're going to have the same as the slope. Now number 3, does the velocity increase or decrease? So I want you to note something. When the graph moves away from the time axis, so this is the time axis. When the graph moves away from the time axis, then we have the increase, right? So here you'll say increase. And then when the graph moves towards the time axis, then it's moving towards 0, which is here. Then you have the decrease, right? So here you'll say the graph is decreasing. Here the move is towards the time axis. Believe it or not, the graph here is actually decreasing. It's not increasing. That's the velocity. So when you get to graph D, the graph is moving away from the time axis, meaning it's increasing. Right, so the graph here is increasing. I'm sorry, here it was decreasing. Let's just go back to it. So it's actually decreasing here because it's moving towards the time axis. You see the move towards the time axis. These are both cases of decreasing, and these are both cases of increasing, number A and number D. So let's go to question 4. The velocity, is it positive or negative? So to determine whether the velocity is positive or negative, we're just gonna look whether the graph is on top of the time axis or below. Here is on top, so you'll have a positive velocity. Here is still on top, it's positive. Here, since it's below the time axis, it's negative. And you have a negative case. Okay, let's go to the final question. Describe the motion of the object as shown by each graph. So here the velocity is increasing. Basically, you've just described by answering the previous question. The velocity here is increasing in the positive direction, right? So this is going to be the answer to graph A. And then graph B, the velocity is decreasing in the positive direction. And here you have the case where the velocity is decreasing in the negative direction, and here the velocity is increasing in the negative direction. So that would be the description of the motion. Now let's go to the following question. The following question says, we will assume that the initial displacement of the object is 0. Consider the velocity time graph with 3 main time intervals. So you've got the first time interval, let's call it Roman figure A or Roman figure 1. Then you've got the second time interval, Roman figure 2. Then you've got the third time interval, Roman figure 3. The question is, calculate the distance traveled by the object. So the distance is actually the scalar, is the scalar quantity. So let's write question A here. For Roman figure 1, we're going to calculate the area under the velocity time graph. So here you have the base of 4 and the height is 8 for this triangle. So the distance would be half base times height. Half the base is 4 seconds. The height is 8 meters per second. So your answer would be 2 times 8, which is 16 meters. So when it comes to Roman figure 2, we have the trapezium. So this is the trapezium. The one side is 8 meters here, right? The area of the so we'll calculate the area of a trapezium. This side is 8 meters, and then this side here is 10 meters per second, and then the height in between them is 4 seconds, between 8 and 4, 4 seconds. So now the area of a trapezium is half height times A plus B, right? Okay, now let's change the color. I want you to notice something. Let's choose color brown. This is your A, and this is your B distance, and this is your H, right? So you say here half height, which is 4, your A is 8 plus your B is 10. So you'll have, in fact, 4 divided by 2 is 2. 8 plus 10 is 18. 2 times 18 is 36 meters. That will be your distance. So Roman figure 3, the distance is going to be the area under the rectangle. So this is a rectangle. It has a base of 2 seconds. The height is 10 seconds. So we'll say base times height is equal to 2 times 10, which is 20 meters. So that will be the distance. So we'll sum all the change in x's. Let's say this was change in x1, 2, and 3. Summing them, this would be 56. 56 plus 16 is going to be 72 meters. So we're dealing with a distance of 72 meters. Now let's go to question B. Calculate the final displacement of the object. So remember, the displacement is a vector quantity. So the displacement, we're going to say for question B, change in x for displacement is going to be the same as the distance, but with a direction. So we'll have 16 plus 36 plus 20, which will give you 72 meters. Then we'll say give it a direction in the positive direction since it's a vector quantity. So that's it. We've come to the end of our today's lesson. If you liked the lesson today, please hit the like button and subscribe. Stay tuned on the next lesson. Cheers.